right, here we go. Functions. A couple things we should probably redefine in case you had forgotten, because Lord knows no one's forgotten anything since you've learned something. It made sense. Is what is technically a function? In algebra, we start talking about things being a function. Do you guys remember what a function is defined of in terms of algebra? Okay, all right, we'll come back to that then. What about domain and range? Remember that? What's range? That would be the difference between two numbers. Yeah, I see what you're saying. It's the range of value, but in terms of the algebra here, that's not the term that I'm looking for. Okay. So let's start over then. Functions. Functions in terms of algebra. For every value in the domain, there exists exactly one value in the range. Basically, that means for every value you put in, you get exactly one value out. For every input, you get exactly one output. You can't input it one value and be in two places at once. Therefore, it's no longer a function. When you learned about functions before, back to this guy here, you guys did stuff like this. You would look at graphs. And when you looked at graphs, you're talking about for every function or every value in the domain, for every input, there exists exactly one value in the output. When you input something, you're talking about what's called the domain. The domain is your x value. Your domain can be all of your x values. Your range are all your y values. For every value of x, there exists exactly one corresponding value of y. If I substitute in for 3, I get 7. If I substitute in -3, I get -12. Whatever. You learned this by doing, on a graph, what was called the vertical line test. Remember that? If you looked at a graph and you put a vertical line, the vertical line represents an x value. X equals whatever that number is. If that x value stays and you're changing your x value, you're just changing where the vertical line is located. If it's touching the graph at one spot, that means that it's a function. For every value in the domain, there exists exactly one value in the range. Okay? Linear, it's a function. Quadratic, it's a function. Okay? Remember what that was called? It's a parabola. You know what that's called? A parabola. It's no longer an x squared parabola, it's a y squared parabola. Is a y squared parabola a function? No, because that means at -4, you're in two different spots. Okay? So it's no longer a function. That's where it comes from. Functions are defined by, for one input, there's exactly one output. For every x, there's one y. Make sense? That's where this comes from. So we talk about, your heroes talk a lot about domain and range in Algebra 2. Remember, easy way to remember which one's which. What comes first in the alphabet? Domain or range? Domain, okay? What comes first in the alphabet? X or Y? X. X values go what direction on the graph? Yes, they go horizontally, okay? Therefore, Y values go vertically. So as we get going, as we get going, we're going to have what's called an H and a K. Horizontal, left and right shift, and vertical, up and down shift. It's stupid, but you're not going to forget it. It is. It's dumb. Horizontal, left and right. Vertical, up and down. Ask somebody who was in this class last year about H and K, they'll go horizontal and vertical. Seriously. Okay. Not bad? Basically, what's going to happen over the course of time. Oh, I know. We're not into this yet today, but do you remember what this was? Not quite. It's point slope form. Very good. We'll talk more about this tomorrow, but you guys have been dealing with, you guys have done point slope form a ton. Okay? Now, y values go up and down, right? I'm going to rewrite this as y minus k equals mx minus h. And we change this to an a. This is going to be a standard form of a linear equation out of point slope. This h and k is just, you have a starting point of x and y, and it moves some horizontal or some vertical. That's where this h and k is going to come into. We're going to have so many equations that have this h and k over the course of the school year. Don't write all this down. We'll have it with sines, cosines, tangents, all of this stuff. Secants, cosecants, cotangents, everything. Okay? Will show up over and over again. All right. We did this, did that. What's slope? Yes, slope is rate of change. Now, when you guys did slopes, we defined it as what? Rise over run. Very good. We did slope. What letter did we use for slope? M. Okay. So we used the letter M for slope. Before we said that slope was rise over run. Do you know why they use the letter M? Yeah, exactly. Look at the word. It's S-L-O-P-E. S looks like a 5. Okay. What's the L look like? 1. What's the O look like? 0. What's P used for in math? Now pi is used for probability. You know what E is used for? Yeah, E is exponential. Okay. Letter E. You'll just wait till we get to that one. You guys are gonna hate me. It's awesome. You'll get exponential functions, principal, compounding continuous principal, things like that. So they started figuring out, well, what are the letters A, B, and C used for in math? Pythagorean theorem. Pythagorean theorem, isn't it? A squared, B squared, C squared. Okay. What's D used for? Dots, no. Diameter, distance. E we've talked about. You know what F, G, and H are used for? H is used a lot for height. F, G, and H usually are written for what's called function notation. F of x, G of x, H of x. We're gonna do compound functions like that, or things. I'm sorry, not compound, composite functions. F of G of x, G of H of F of x, things like that. That's where all those letters come into play. I, do you know what I is used for? Nope. Imaginary numbers. Numbers you can think about, but you can't talk about. Imaginary numbers. J and K, do you know what J is used for? Yeah, J, just kidding. No. So, you guys ever heard of what's called direct variation? X and Y vary directly. That means there's some constant multiplier to them. And direct variation is the precursor to slope before we gave you guys a y-intercept. Y equals 2x means your constant of variation was 2. Your slope was 2. That's where that came from. J and K are used with what's called joint variation. X, Y, and Z vary jointly with Y. So there's like 3 things being multiplied together with a constant. K is also thrown in with that joint, what's that called? Compound or whatever. So then they kept going. Then L, we just talked about L. They got to M. They're like, who's using M? Let's use M. Because then you get to N. N is like number. O doesn't work. P doesn't work. Q looks stupid. S is 5. T is time. U is under something. V looks like a U. W is weight. X is you're always looking for. Y is what it always equals, and Z is third dimension. So the only really letter that was left was M. It is. X, Y, Z. Do you guys not know that? Merry Christmas. I know you really, really wanted to know that. Don't lie to me. All right, so you guys said a second ago. You said rise over run. What values on a graph are the rise? Y's. So do you guys ever write it as the change in Y or the change in X? Do you guys know what the triangle stands for then? Delta. Delta change. So if you're given a set of ordered pairs, basically as you label them, and I know you've done this before, as you label them, the first set of ordered pairs, the second set of ordered pairs, as long as you're consistent, normal people, us mere mortals, read from left to right, so we would call the first one the X's and the second one's the Y, the second ones. We would write it as the, and I think this is where you were getting that, change part, where you were getting the rate of change, what the difference between the two objects. How many types of slopes are there? 4. What are they? Yeah. No, just what kind of slopes are they? Show me. Okay. 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 Okay, there you go. We'll go in her order. Four types of slopes. Now, if your line is going up and to the right, what kind of slope is it? It's positive. Because when you start thinking about quadrants, you're positive, positive, negative, positive, negative, negative, and positive, negative, correct? If you're going up and right, you're going positive divided by positive, which is always positive. Isn't up and right the exact same thing as down and left? Good job. So a negative divided by a negative is always positive. That's where this comes from. So this is your positive slope. What kind of line is that? It's straight. It's vertical. Vertical lines have what number always in common? The x. The x value is always in common. Which means the denominator is always going to be equal to 0. So your slope when you have a vertical line is an undefined slope because you cannot divide by 0. Which means then when you have a horizontal line, what's changing? Your x values are changing, but your y values stay constant. So if you have the same y value, you have 0 in the numerator, which means this is vertical. If this is horizontal, your slope here is 0. Because what's the second letter of the word horizontal? Oh, 0. And then lastly, the other one by process of elimination gives us negative slope. Okay. Super easy, super pretty quick to work with, nothing too crazy. Do you ever write slopes as mixed numbers? No, because how do you walk 3 5/8? You do. I mean, that's great. I like the positivity, but it's not going to work very well. You know, it's much easier to go up 29 and go to the right 8. Correct. Okay. The fridge. That's the fridge. It's William Perry. A little before your time. The big guy. William Perry was a defensive tackle for the Bears. Stole Walter Payton's touchdown, he did. But back in 85, 86, when he was a big guy, he was maybe 5'10", about 305, and he was like the biggest lineman in football. That's like a, yeah. I mean, seriously, you go ahead, yes, sir. That's why people called him that. He did a couple of commercials. He did a Buick car, or Buick Renault car commercial, and his tagline, "Open the door, the light goes on." That was really cool. I'm sorry if I try to share with you anecdotal things about stupid stuff. Do I have to do an example of how to find slope? I didn't think so. We did this. Oh, parallel and perpendicular. Parallel lines. Remember how to do this? If your slopes are parallel, what are they? Same, good. You guys remember these symbols, right? So parallel slopes are same slopes. Perpendicular would be what? Opposite. Reciprocal is good. For example, if your original slope was equal to negative 2/3, what's parallel to negative 2/3? Negative 2/3, good. Okay. What's perpendicular to negative 2/3? Positive 3/2, good. All right. If your original slope is 0, what's parallel to a 0 slope? Okay. What's perpendicular to a 0 slope? What kind of lines have a slope of 0? No, try again. Horizontal. What kind of lines are perpendicular to horizontal lines? What's the slope of every vertical line? That's fine. This is the most common mistake when we get into slopes by parallels and perpendiculars, especially with horizontals and verticals. It's so easy, you forget. Okay. Remember what slope of 0 means. Doesn't matter where the lines are located, doesn't matter the equation whatsoever. If you know that the slope is 0, That means what's perpendicular to it has to have a slope that's undefined. Y equals a number is always horizontal. X equals a number is always vertical. And there will be shortcuts as we get into writing equations, which we won't have time to do today. On the calendar, and I need to edit this now before we get too far, I told this to first hour, excuse me. All I want them to do is just the 2.2 stuff. Those, what, 7 problems, 6 problems? That's all I want you to do tonight. Just look at those, that 2.2, those 3, 5, 6, 7, 8, 6 problems. Do those 6 problems on here. We obviously do not have time to get into the rest of it. We will get into more of that stuff tomorrow. Okay. So, oops, I have to copy. I still didn't copy. Anyway, just do those. And then 2.2 graph is right here, okay? It shouldn't take you more than 6 to 7 minutes. Nothing? Guys, heads up. Quick. This question is real good in case you forgot. To get to the PDF, go to where it says altitude here, click on it, it'll say more details. Click on the more details, and that's where it comes from. Okay, you just have to click more details. And it should pop up. I'll be right there. Okay? Suggestion. Open that PDF now. Go to the page where the problems are. Screenshot it. That way you have it. Take a picture of your phone real quick. That way you have it. You don't have to. I'm just saying if you wind up with bad internet, that way why you have the internet. CYA. That means something. I don't know if you know what that means. I'll bring your. Sometimes I'll say the wrong words. Over your apples is right.